Welcome to the General Chemistry 1 class. This section is on chemical reactions and chemical equations, focusing on mass conservation and chemical reactions. In this lesson, we will interpret the meaning of balanced chemical reaction in terms of the law of conservation of mass. Balancing chemical equation is necessary since chemical reaction they represent are governed by the law of conservation of mass. If we can recall, the law of conservation of mass states that matter cannot be created nor destroyed. It can be transformed from one form to another. In a chemical reaction, the mass of the materials before and after the reaction is maintained. Looking at the combustion of methane, we can see that all elements found before combustion are still there after the reaction. To illustrate in another way that chemical reactions obey the law of conservation of mass, the total mass of all the reactants must be equal to the total mass of the products. Given our previous example, the corresponding chemical equation for the combustion of methane is given as methane plus oxygen producing carbon dioxide and water. If the equation is not yet balanced, we can see that the total molar mass of the reactants is not equal to the molar mass of the products. If we now consider the balanced chemical equation for the reaction, in which oxygen and water have coefficient of 2, we will see that the total mass of the reactants is equal to the total mass of the products. As you can see in the illustration, in the product, it has 80.042 grams per mole, and in the reactant, the same molar mass. Let us have an example to illustrate the chemical reactions obeyed by the law of conservation of mass. Burning of barium occurs according to the following equation. 2 moles of barium plus 1 mole of gas producing 2 moles of barium oxide. Question number 1. What is the molar mass of the gas? And question number 2. Which of the following is the identity of the gas, O2 or O3? To answer that question, let us consider the law of conservation of mass. With this, 2 times the molar mass of the barium plus the molar mass of the gas equals 2 times the molar mass of barium oxide. Barium has a molar mass of 137.33 grams per mole, while barium oxide has a molar mass of 153.33 grams per mole. If we let X equal to the molar mass of the gas, the equation becomes 2 times 137.33 grams per mole times plus X equals 2 times 153.33 grams per mole. Solving for X, we have 32.00 grams per mole, or 32 grams per mole. For number 2, we have two methods to deal with the problem. For the first method, calculate the molar mass of the given choices. The gas with molar mass closer to the calculated molar mass is the identity O2 has a molar mass of 32 grams per mole, while O3 has a molar mass of 48 grams per mole. The answer is number 1, 32 grams per mole. So the identity of the molar mass, the identity of the gas is O2. For method 2 by inspection of the chemical equation, we can see the product side has 2 barium and 2 oxygen atoms. The reactant has 2 barium atoms, an unknown element. To maintain the equality of both sides of the equation, the unknown must be molecule with 2 oxygen atoms. Hence, the unknown is O2. To summarize, chemical equations must be balanced to obey the law of conservation of mass in chemical equations. Here is our references or bibliography, and thank you.